Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy downhill day to you, and I have good news and further good news and just loaded with good news today. As they say down under, heaps of good news. That's heaps, which means lots, and they pronounce it heaps of good news. So anyway, first, I wanted to show you that I'm going to make a point. This is the statistics for the Baylor Bears. Why the Baylor Bears? I think they are going to be in the finals of March Madness. And then I'm hopeful Gonzaga will play them. I don't know how often Baylor and Gonzaga have been there, but they're not exactly, the college basketball teams that come to mind first when you think, I wonder who's going to be, in the finals, or as they say in Australia, the grand final of March Madness. Well, I hope it's Gonzaga and Baylor. I think Baylor is already seeded, but I want to point out something to you. 3-point percentage. 3-point percentage. Baylor hits 41. I can't believe this. I'm going to have to check this with my daughter Lisa, who's my basketball statistician expert. It says they hit 41.8% of their three shots. Wow. No wonder they're there. That is unbelievable. Now, how did they get there? And my daughter Laura would want you to see this point too. How did they get there? How could you get really good at shooting threes or free throws? Their free throw percentage is about 70% team-wide. Pretty good. 7 out of 10 on average, the whole team. It's pretty good. And the best free throw shooter on the team, and I hope he's a starter, looks like one of the guards is an 86% free throw shooter. How did they get good at that? Practice, 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 practice. I'm just making the point. That's how you get good at anything. How will you get really good and ready for this test tomorrow that you're about to take and that I'm going to go over today? Practice, 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 practice. And using your journal and triple R'ing it. Now, it'll be kind of easy, and as a teacher, there are a number of variables that what goes into, making individual students that you have in any class. What are the variables that go in to causing them to have the grade or score that they have on an individual test? Well, it involves study, that's for sure. Triple R'ing is one of the variables, a big-time variable. So it's not everything, but it's often the test score is a measure of how much triple R'ing occurred. So I'm just saying, go for it. I'm going to tell you the topics. I'm going to tell you every topic. I'm going to build the test on those topics. They're going to be listed in homework notes on Wednesday night. They will be listed. In fact, I'm probably just going to put them in 7th grade because it's going to be almost identical for 7th and 8th grade. Not quite. You'll see in a little bit. So anyway, I wanted to point that out to you, which I think is kind of cool. And some of you may have been down on the Baylor campus in Waco, Texas. We have. We have a relative in our family who graduated from Baylor a few years back, and we got to go down. Did you go to Magnolia Table? No, we couldn't. So, the HGTV program. But we did go, Fixer Upper I think it was. But we did go to their other location and spent some time there, hanging out there. So, anyway, we think a lot of those people, and I think they're believers. Hey, I want to show you John 1:3 again. You're going to write it tomorrow. John 1:3. And this Greek word right here, panta, right there, panta in Greek. Panta means all, and it's the all things through him came into being. Jesus is talking about. Okay? So, and I've got a bonus point for you too, but I want to show you this as well. I showed you this earlier in the week, and here it is. Because in him, there's panta again, in Colossians 1:16. In him all things, in the heavens and upon the earth. That's all, folks. When it says all, it means all. This is the New Testament. This is New Testament, the original Greek. All things in the heavens and upon the earth, the visible and the invisible, whether thrones or dominions or rulers or authorities. There's panta again. Panta. Diatu. Through him all things, and for him, have been created. He deserves our worship this Easter season. So, anyway, I am so excited about Holy Week this week, and realizing, and I'll come to this later, realizing that I was in Jerusalem last March, and I was in, most likely, can't prove it 100%, but I was in the tomb, the empty tomb of Jesus. He wasn't there. And I showed you yesterday that this guy, taking a while to come up, and this guy, Gary Habermas, has proven historically. There's Gary. He's written a many hundred-page volume now book on evidence, data. You could say science data. It's historical data, but it's data. So, in a broad way of speaking, it's science, proving that the resurrection happened. So, and also citing many historians who are atheists, don't believe the Bible is God's word. They don't believe Jesus is God's son, but they believe he rose from the dead, or he was in the tomb and he was dead and then he came out of the tomb. I don't know how they can believe that and not become Christians. You know what I mean? I don't get that. But anyway, that's the way they are. So anyway, good on you, Gary Habermas. By the way, there might not be very many of you. There could be a few of you. If you go on YouTube and find Gary Habermas, you can watch a video of him giving the specific data that proves that Jesus came back to life historically. Now, we don't need that proof, but we've got it. History and the Bible are linked. They're glued together. So, and it's a wonderful thing. But if we just had the Bible, that would be good enough data for us. Yeah? It would, wouldn't it? So anyway, there's Gary Habermas. Now, I'm going to go over, you've got your test tomorrow. Mr. C, how many points? 40 to 50. I don't know yet. I haven't written it. When are you writing it? This afternoon, probably. Tonight. Tomorrow morning. So, and remember, I'm taping this on Tuesday for Wednesday. So anyway, here are the test topics. John 1:3, all things were made by him, and without him nothing was made that has been made. And it says in the Greek text, not even one thing without him was made. I love that. I love it. I love it. Colossians 1:16 and 17, I'm going to ask you to finish this phrase from Colossians 1. And in him, speaking of Jesus, Colossians 1 is all about Jesus. And in him, Jesus, all things, panta, hold together. I'm going to ask you that verb, hold together. All matter holds together because of him. So I'm going to ask you that verb. Some of you are going, you're not paying attention right now, and I'll ask you this question. Hey, in Colossians 1:17, what does it say? In him, Jesus, all things, and you have to finish it. The verb, hold together. That's 3 times I said it. So that'll be a little test how many of you were paying attention at this point, or picking your nose. Hopefully not. Not literally, that's a figure of speech for not paying attention. Okay? So anyway, I'll probably ask you a question about Gary Habermas. I'm probably going to say he's a historian, a brilliant historian, and he has historically proven what to be true? That the resurrection of Jesus occurred. Yeah, I'll ask that. So, and I just want to make the point, everything depends on the resurrection for us Christians. It says in 1 Corinthians 15, if he didn't rise from the dead, then none of all that we hold dear in the gospel is true. But everything is true because he came back to life. So what does it mean? The gospel's true. The gospel says Jesus died, he was buried, he rose again on the 3rd day. We ask him into our life and we become new creatures. He changes us. I'm not the jerky person that I was 60 years ago. So 65 years ago, I was a selfish jerk. Jesus has changed me quite a bit. I care about people a whole lot now. Not because of me. I didn't do it. It was him. He did it. Changed me. So, now, all we hold dear, asking Jesus in, him transforming our life, wouldn't happen. We, having answered prayer now and being blessed by him every day, him always being with us and never leaving us, all of that couldn't happen. But it can happen because of the resurrection. It's that important. It's that foundational. And then living with him forever in heaven. Kind of like le pièce de résistance, the frosting on the cake. Living with him forever in the most beautiful, gorgeous place we can't even imagine. And the most peaceful, joyful, full of joy place. Just full of love headed our direction. Wow, it's just, we have no idea. It's going to be so gorgeous. Okay, I'm going to ask you some things about the periodic table. Now, 7th, 8th grade, at this point, I'm going over things that are going to be the same for 7th and 8th. So, I'm going to ask, just for a little bit, about how many different elements are they? About 100. What are the individual building blocks of all matter called? What are they called? They're called elements. Periodic table of the elements. So elements. Okay? So I'm going to ask you for a definition of matter. Matter, anything that has mass and takes up space or has volume. And matter is made of these. It's what Jesus made matter, the panta, the all. He made the panta out of these elements. He spoke them into existence out of nothing. The ones you've got to know so far, and their symbols. You've got to know the 2 gases found in the sun, hydrogen, helium, 2 gases found in Earth's atmosphere, oxygen and nitrogen, mostly nitrogen. The C element that our tissues are made of, so carbon, and then the Fe1 for the really dense metal called iron. And it's responsible, when it combines with oxygen, for making rust, that rusty color, the orange color, in our soil, here in Arizona even, and in the soil on Mars. So those 6. So, and then I'll come back 8th grade, and I will, toward the end, mention the other 4 that you've got to know. So I will get to those in just a minute and tell you a few other things about the periodic table that you've got to know. Now I'm going to ask you this. An element plus an element makes a compound. Element, compound. I've gone over this almost 10 times, probably, more than that. If you miss it, it means you weren't paying attention. Element, compound. So carbon combines with oxygen, you get carbon dioxide. Hydrogen, H combines with oxygen, you get H2O, or glug, 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 wah, wah, water. Those are compounds. So the smallest part of a compound is a molecule. I'll ask you that tomorrow. Smallest part of a compound is a molecule. So the smallest amount of water that you can have is a molecule of water. The smallest amount of carbon dioxide gas that you can have, O2 in, CO2 out, carbon dioxide. The smallest amount of carbon dioxide coming out of my mouth, probably millions of molecules coming out. Molecule being the smallest. And then the smallest part of an element is an atom. So, and then I'm going to ask you for the parts of an atom, all of you. Parts of an atom. What's the center of an atom called? A nucleus. The nucleus. You know, I don't think I put down nucleus. I should have. What's wrong with you, Mr. C? Sorry about that. There it is. I'm looking. I don't think I put it down. The nucleus. In the nucleus, you have protons, positive electrical charge, and neutrons, neutral charges. And you have negatively charged electrons orbiting the nucleus. And all of this is very much like a fuzzy cloud because of the speed that the electrons are orbiting. So anyway, there you have it, the parts of an atom. I'll keep going. So in particle physics, I could show you this. I should show you this. I think I've got a number of pictures. I want to show them to you. So I think this is still up over here. And there it is. Yeah. The standard model of particles. There it is. The two main kinds of basic particles. Simplest particles that everything is made of. You can't get any smaller. You can't divide them anymore. Quarks, silver on the left, quarks, and leptons. An example of a quark, a proton, I'll ask. An example of a quark, a proton. An example of a lepton, it sounds like it. An electron. Lepton, electron. A proton, a quark. And neutrons are quarks as well. So that's the standard model of particles. So I wanted you to see that. So goodbye. Goodbye, standard model. And then I wanted you to see this. And here they are. I think I've got all of these. The four forces, are they here? The four forces of, I actually don't have it. The four basic forces that kind of hold the universe together. Number one, gravity, right? Gravity, the attraction that everything has for every other thing, Isaac Newton said, his universal law of gravitation that he came up with in the 1600s. So you've got gravity. Then you have the electromagnetic force, where you've got opposite charges, like the electron and the positively charged nucleus attract each other. Opposite charges attract, like charges repel. I've been over that a bunch of times. Opposite charges attract. Like charges, like protons in the nucleus, should repel, but they don't because of it's on the test tomorrow, the strong nuclear force, the third force. So we've got gravity, then you've got the electromagnetic force, then you've got the strong nuclear force that holds protons together, holds all matter together, really. I'll probably ask the question something like this. What force of the four fundamental forces is it that holds all atoms together, and therefore all matter, and prevents them from flying apart? The strong nuclear force. I've told you that a dozen times now. The strong nuclear force. And then the weak force allows fusion to occur. Hydrogen, hydrogen, hydrogen. fusion, I'll ask you about that, on the sun and other stars, and it produces different elements. Hydrogen make helium, a different element, and heat and light. Okay, so that's the weak force that allows an element or an atom of an element to change from one kind to another. To decay, it's called, to change from one kind to another. So hydrogen into helium. So, and then there's a number of other ones. Uranium does that, and some of the radioactive elements, which 8th graders we will get to later. So anyway, wanted to show you that. Now, let's see what else I have. How are we doing time-wise? Pretty good. Got at least 10 minutes left. So that I showed you the standard model. The Large Hadron Collider, I showed it to you yesterday in Switzerland, Geneva, Switzerland. What is it? It's a collider. What does it do? It collides what? It collides hadrons together. A hadron, an example, would be a proton. So it smashes protons together. I'm going to ask you why. Why do they do that? Why do they spend $10 billion or more in building this monster collider that collides protons, which are hadrons, together, so they can find other particles? Now, they wanted to find the other particles because they were hopeful they'd find evidence of the Big Bang. They didn't. They found particles that have a specific mathematical value that they didn't want them to have, because it shows fine-tuning of the universe. That particles have specific values. So, and different other things in the galaxy, the Milky Way galaxy, like the speed of objects, the gravity of objects, the mass of objects, all fine-tuned. Specific, non-accidental, they are non-random, they've been designed, values, mathematical values, fine-tuning. Well, that's the Large Hadron Collider. You've got the 4 forces. What do we call this invisible field that gives particles their mass? What's it called? The Higgs field. So I'll probably ask it to you this way. I won't have you remember the Higgs field. I'll probably say, what does the Higgs field do for basic particles of matter? And you'll say, it gives them mass. M-A-S-S. I've already said it a half a dozen times. It gives them mass. It's mysterious. We don't understand it exactly. But because of the Higgs boson particle, so I'll probably ask you a question about the Higgs boson. I'll say it like this. The Higgs boson particle showed that there's got to be a Higgs, and you'll say, field. And then what does the Higgs field do? It gives mass to the particles, we think. It's so mysterious, though, we do not, absolutely do not know everything about all of this or all of the particles. We don't understand bosons, which make sure that the forces work properly, the four forces that I told you about. Gravity, the weak force, the strong force, the electromagnetic force. The boson particles make sure those operate properly. Again, tremendous mystery. It brings God tremendous glory. So if I say to you, all of this mysterious stuff about the particles and the Higgs field and the Higgs boson, all of it, what does it do for God? It brings him great glory. It makes him look really good. It magnifies him. It shows how awesome he is, because all of this stuff is, some of you are going, Mr. C, this is so complex, my head is going to explode. I might ask that question tomorrow. So during this time where we've looked at the particles, the basic particles that everything is made of, that you can't subdivide, and the Large Hadron Collider, and the forces, many, many times probably you thought your brain was going to, and you'll put, explode. So anyway, do you think I'll put that question in? You know me, you never know. So don't be surprised if you see it. Okay, I'm getting there. Fomin, the Fomin pillars are going to be there, of course. of evolution, and it turns out the pillars of evolution actually don't strengthen the pillar or hold it up, they crash evolution. Because the data for all these pillars crashes it, because the data is so poor. Fossils, no tweeners, no ape men, shows there was a great global flood like the Bible says in Genesis 6, 7, and 8. So that's bad. So for evolution, the old pillar, the old age pillar, turns out there's evidence for lots of young age, thousands of years, not billions. So that's bad. That doesn't work. That doesn't hold it up. That side of evolution comes crashing down. Figure of speech. Remember my favorite young ages for the solar system and for the Earth. The comets keep coming back. They should have all melted. One of my favorites. You know the dinosaur bones one, where they still have red cells in them. They still haven't hardened up enough in many cases. And they also have DNA in them. All of that should have broken apart, decayed in a few thousand years. So that means they're not that old. Okay? Tremendous evidence for a young age for the Earth. And then the A pillar, the laws, law of cause and effect, and law of biogenesis, life causes life. So the A pillar or accident pillar, it can't be an accident. You got to have causes for everything. You got to have life making life. And living things are way too complex. Everything's way too complex. If it's that complex, it's got to have a complex designer, creator. So, and then you've got the two mechanism pillars that are really bad. Mutations stink. They are rare. They're harmful in most cases. And they're fatal in many cases to living things. So it's not a good way to make things change for the better. Nor is natural selection. Natural selection doesn't make change. It gets rid of change. And then you've got the Big Bang pillar. Well, there's so much evidence that it couldn't have happened. Where'd the particles come from? How'd they get there? Why would they come together? Why would they have enough mass? Why would they cause a massive explosion? We'll pretend there was a massive explosion. If it occurred, why would it cause rotation? And why would it cause complexity? And why would it cause specific individual things to form? It wouldn't. So it just doesn't make sense. So anyway, that's going to be on there. So, and then the gray whale. So, do I have a picture of it? I think I still got a picture of it here. See if I do. Yeah. Gray whale. Give me a couple of divine designs for the gray whale. Well, first, the baleen that you see. It's the filter that filters out its food. When it eats, it closes its mouth, squirts the water and mud out, and it keeps the little crustaceans and the other little small animal life, mollusks probably, keeps them behind inside, and it swallows them. So it has a sleek body. It's really got thick layers, probably several feet thick of blubber to insulate it. So, and they know when and where to migrate to, so they can have their young, and their young won't die of hypothermia, but will end up being in warm waters off of Mexico. So they'll be okay. Anyway, the gray whale, one of my favorites. So I think I told you I went on a gray whale expedition, and we had gray whales come right up to our boat. So, and I just missed getting to touch one. You don't always get to, so that was pretty cool. So anyway, by the way, it might be a bonus point. There's two kinds of whales. There's whales that have baleen, and there's whales that have teeth. So, now, 8th grade. Listen to all of this. Who knows? This is for 7th grade, but listen to it. 7th graders. The layers of the earth. Crust, mantle, outer core, inner core. It'll be on the test. Remember that 8th grade? Crust, mantle, outer core, inner core. The outer core and the inner core are super hot. The outer core is liquid rock, magma. The inner core should be magma, but the layers of pressure above squeezing on it don't allow it to become a liquid. So, and 7th graders, you also have to do NICS, the characteristics of minerals, naturally occurring, inorganic, not from organic things, not from living things, unique crystals, unique chemicals designed by God, unique crystals, chemicals, and solids. You've got to know what the characteristic of a mineral is. That's a property. You've got to know what density is. Density is how tight matter or these minerals are packed. And you've got to know three kinds of rocks. SIM, sedimentary. 8th grade, you recall this? So sedimentary rock. Remember, my other favorite, young age pillar. That the layers in between the sedimentary rock are smooth. That means they were laid down quickly. They didn't have time to erode or wear away and become uneven, non-smooth. That is so, I love that one. That is such a good one. Okay, so anyway, and so put my train back on the track. Woo woo, back on the track. Going down the track, three kinds of rocks. SIM, sedimentary, SI for igneous. My favorite igneous rock is right here. It's amethyst. I bought this in a gift shop, a naturalist shop, a science store in Sydney, Australia. Those purple quartz crystals are so gorgeous. So that is, by the way, this is going to be in heaven. The gate, some of the gates of heaven, one of the gates are going to be made of amethyst. If it's the same as this stuff, that's what it's going to be made of. Oh, I'm so glad about that. Thank you, Lord, for making one of your heavenly gates out of a mineral. That's my favorite. So he didn't consider me. He did it long before he knew I'd love amethyst, purple quartz. So, and then 7th grade, we're about done with you, and then 8th grade. 7th grade, liquid rock underground, magma, 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 magma. 8th grade, remember this? Lava, 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 lava. So up comes the magma, 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 comes out of the ground, and lava, 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 lava. So, and then I have examples just really quick. 7th grade, examples of these kinds of minerals. So first, this is sedimentary. This is shale. Used to be mud, most likely buried by the Great Flood. Even looks like mud when you examine it close. Then igneous. I have another igneous one right here. This is volcanic glass, black volcanic glass, aka obsidian. So you could use that, or amethyst, or quartz. That would be fine. Or granite. We've got granite all over the campus. So, and then metamorphic, SIM, shale gets heated and squeezed underground, becomes slate. Shale, I should do it this way, left to right. Shale to slate. Shale to slate. I'd stick that in your journal if I were you, 7th grade. 8th grade, no. Shale to slate. Shale to slate. Okay? So, examples of the three kinds of rocks. And then 8th grade, this is for you. 7th grade, pay attention anyway. Here are 4 additional minerals that you've got to know. And I've got them right here. First, this, as they say it in Australia and the UK, aluminium. Aluminum. It's a very light and a very malleable. That means you can shape it into all kinds of different shapes, like an aluminum can. So, aluminium, Al. And then I've got, do I have examples of these? Then you've got Cu copper, copper metal, Cu copper, 8th grade. You'll have to know it. These are additional ones. 7th grade, you don't need to know these. Al, aluminium. Now, what is Al if you pronounce it? How would you pronounce it? Al. Cu copper. So, and then also there was Si silicon. Si silicon, computer chips are made of it. shave it into thin wafers and etch it with electrical circuits, little microcircuits. Si, silicon. So, and then the other one you've got, do I have it up here? I think I do. Maybe. Yeah, I do. Here it is. This is the liquid element mercury. It's on the cover of your 8th grade chemistry book. Mercury, Hg mercury. It'll be one of the 10 you've got to know. So you already know the other 6. So I wanted to show you all of those. And I think that's about it for you guys. One last thing. 8th grade, I wanted you to know kind of the 3 major groupings of elements. You've got lots of metals. Then you've got the metalloids in the middle, which have some properties of metals and some of non-metals. Okay, so you've got metals, metalloids, and non-metals. Okay, and then I wanted to show you this really quick. I hope I still have this picture up. See if I do. I love this picture. When I was in Jesus' tomb in Jerusalem, I hope you can see this. This might have been Mary Magdalene. Someone just painted this. One of the first to look into the tomb. And she sees it's empty. I have goosebumps. It's empty. He's alive. So, and that's what they would have seen. I love that. Empty tomb. So, pretty cool. Well, triple R for your test. And he is risen. And some of you are thinking, because you say it in your family or in your church, he is risen indeed. That's the way Christians celebrate Easter. He is risen. He is risen indeed. I will have your test all set for you tomorrow, Triple R.